Awesome. Okay, good to see you all again. Welcome to week 5. How's COMP1531 going? Good? Okay. Ish? Good. Cool. Shall we get into it? All right. So I come in, just can you pull the door shut so it latches when you, yeah, thank you. I'm really glad we're doing this lecture because if you remember last week we were writing some code with callbacks and I realized that we didn't actually, you hadn't seen what a callback is or we hadn't spoken about it, right? Yeah? And so today actually is the lecture in which we're really going to break down what's happening. And it's a really fundamental lecture and it's actually just very interesting. And it can be a little bit tricky, so I want you to pay attention and to write. I think what's really important for this lecture is to write the code along with me, okay? This is not just so I actually was looking at all the lectures and I renamed this lecture 2 hours ago. It was called Advanced Functions, which I think is not a good name. So I've renamed this lecture to Functions Are Data Now, which may or may not make sense to you. Has anyone done any functional programming before? Do you know, okay. Has anyone else heard of it or done it? We've not heard of it at all? Good. So a lot of these ideas in JavaScript and TypeScript are borrowed from functional programming languages, although JavaScript is not a purely functional programming language. A lot of ideas in JavaScript and TypeScript are also borrowed from object-oriented programming languages. Who's done 2521? You've done OOP? You're doing it now? Okay, so you're learning all about OOP. There's a lot of ideas from OOP in JavaScript, but JavaScript is not an OOP language. So what's happening more and more with more modern programming languages is they're borrowing a lot of ideas from many different paradigms. In the 90s and the 2000s, when a lot of these paradigms were becoming useful, in fact, in my office, I've got a book colloquially known as the Gang of Four. Has anyone heard of it? It's a book on object-oriented programming design patterns. It was everyone read that book if you were learning programming, 20 years ago, 30 years ago. But no one reads it anymore. And no one really writes only object-oriented code, and no one really writes functional programming only code. Some people do, actually. I'm going to get flamed online. But a lot of really good ideas made it into JavaScript and TypeScript, and you use them all the time, and so now we're actually going to understand them. Does that sound good? Okay. Yeah. A lot of these names even come from functional programming, and actually just mathematics. Mathematics is generally quite functional. All right, so how big is the code so we can sort of see it? Okay. So let's just talk a bit of JavaScript, and actually I would say this is more TypeScript syntax. Have you also spoken about JavaScript versus TypeScript? You have? So that distinction is obvious. So I think most of the code snippets in this lecture are TypeScript, but it's the same language, right? TypeScript is not a language that gets executed. So it's all the same. Okay. One of the things that causes a lot of people a lot of problems in JavaScript/TypeScript is there's a lot of different notations to do the same thing. And there's lots of reasons for it. The language has evolved over many years. JavaScript very famously was written in, does anyone know how long the language was written in? 10 days. Yeah, something like 9 or 10 days. So it was not a very well thought through language. If you compare that to something like Go, who's heard of the Go programming language? That took over a year or two for the first specification, I want to say. Anyone know who wrote it? He lives in Sydney. His name's Rob Pike, and he actually gave a guest lecture in this course 2 years ago. And you can find the video on YouTube. It's actually very good. You should go watch it. It was when LLMs were very early, and people were asking him about LLMs, and it's interesting to see how it stuck up. So yeah, JavaScript was written it was kind of thrown together to just do stuff in the browser. And so for that reason, over time, people have added features and things to make it easier. And one of the things we're left with is that there's 3-4 ways to do many things. One of them is just so simple, it's kind of shocking, but to declare a function in JavaScript or TypeScript, there's 3 ways to do it. I think what I've got here is the original method going down is the more modern methods. And we can talk about what drove this motivation. So if we look at the top few lines, do we see method 1? Is that viewable at the back? If it's not, you know what I'm going to say? Come to the front, yeah. Okay. All right, so we have a keyword function. So like many programming languages, we have this keyword that denotes whatever's going to follow here is the declaration of a function. That's makes a lot of sense, right? So the function keyword, what's the name of the function? Add, yep. What follows the name of the function? You can just tell by reading this, right? You're all programmers now, hopefully. The parameters, very good. And in this case, there's two. One's called A, one's called B, and they're both numbers because this is TypeScript. I'm adding some type information. Then we've got that colon number. This is a TypeScript-only feature to say that, well, this function's going to return a number. Obviously, if this is JavaScript, you wouldn't have that. Then you've got a pair of curly braces. This is what? C-inspired syntax. Yeah? You know, in C, int main, curly bracket, you know, parameters, curly bracket, that block is the code that will execute when that function is called, which is different to Python, which uses what? White space. They don't use braces. So anytime you see braces like this, it's C-inspired syntax. And then whatever's in the function block is what gets executed when the function's called, and if there's a return statement, if it's a function, something will get returned. So it's pretty straightforward. Yes? Okay. What was the title of the lecture? Functions are data. So if you can see now on method 2, a function expression, it's very similar, right? But what's the difference? I mean, I don't want you to know internally the difference. Just look at the syntax, like what looks different. It's being assigned to a variable. Agreed. There is slightly more to it, but the syntax is different, right? That's right. You don't have the name of the function. Right, we can see that. So the name of the function now is actually associated with the variable in which we're storing the function. Now, what does this tell you? Well, this is a function and it's data. That's hence the title of this lecture. Functions in JavaScript are just pieces of data. In fact, they kind of always have been. And actually, you know, in fact, it might have been 25T2 when I taught 1511. Maybe, I can't quite remember when it was. But you can actually do this in C. How would you do it in C? Function pointers, very good. Did I do that in 1511? Anyone remember? I definitely have done it in 1511 lectures, but it's like a kind of thing. But functions are stored in memory. So if we know the address of that piece of memory, we can pass that memory address, and as long as we tell the caller that this is a piece of memory which contains a function, you can call it. It's actually very useful. It's actually so useful that JavaScript runs on this whole paradigm. So all functions are really memory addresses to a piece of memory that contains a block of code which is an executable function. And this is what we're exploiting here. So when I know that this is there's no type on this add. But what is, well, there actually is, but what is the type of add? No. Guy, who said that? Yes. It's a what? Say it louder. Function. It's a function. What are we assigning to add? A function, yeah, definition. We have not called this function. Right? Agreed? So what is the type of add? It is a function because functions are data, right? I said it would be a bit tricky. Now, method 3 is, I would say, mostly syntactical improvements to method 2. So the idea was, well, why do we need this function keyword? We can use the brace syntax to indicate that this is a function. And why is this a little bit more preferred? Well, it's actually more consistent. We've actually seen this. Where did we see it? We saw it last week. How good is your memory? Is that a hand? Is that a hand? In the callback, which we passed to which function? It was app.listen, right? So remember we had app.listen, we opened a brace and we passed it a pair of braces with some stuff in it and then the arrow syntax. So what did we pass that function? Nothing. Good try. Sorry. No, we pass it a function. So when we see this syntax, it's a function. So let's just look at this syntax. Well, this is the same as this, right? Agreed? This is saying, well, this is a function. This is saying, well, if I've got those curly braces, I know it's a function. So we don't have the function keyword. So this function, what parameters does it take? A and B, they're both, right? All three of these methods, it's the identical function. A is a number, B is a number, that's the function. Its return type is a number. And when the function is called, this is the arrow syntax, execute the block. And that gets stored in add. So if I wanted to call that function, what would I call, on the next line here? ADD, open bracket, a number, comma, a number, close bracket. Yeah, exactly right. Because functions are data. Got it? Who's following? Because we're just getting started. Who's not following? You can be honest. Yeah, these three things do the same thing more or less. There actually probably will be very, very nuanced differences with these three methods of declaring a function. There could be performance differences. There could be scope differences. In fact, I'm pretty sure there are. But I'm not such a TypeScript optimization expert to be able to rattle those off the top of my head. If you're really curious, you could copy this code block probably, honestly, into Claude or ChatGPT and ask it what are the performance differences between those three approaches. And that would be a good way to use AI in your learning, not what everyone else is doing. Anyway, so methods 2 and 3, they're treating a function declaration as if it's a variable. That's very, very, very important. And we will exploit this in JavaScript and TypeScript very frequently. It's very useful. Typically, you want to be writing method 3 in JavaScript. It's funny, if you look at a code base, the older the code base, the more like method 1 and 2 you see. The more modern, you might rewrite it to use method 3. It's just sleeker. It's shorter. That's really why it's preferred. All right. We sometimes, I think you can call them inline function declarations, but sometimes a function is so small, simple, and reusable, we can even just declare them on one line. So look at the down over here. We have this method that doubles the parameter the argument that's passed into the function. The calculation is so small, so we can just do n times 2. There is a key difference between these two examples, though. What is it? There's no curly braces, which is just like in C. If in C, if you've got an if statement that's on one line, you don't need curly braces, right? There's another difference. So there's no return keyword, but it does return. So on an inline function declaration, when there's no curly braces, it's what's called an inherent return. So the resulting value of this expression is automatically returned. So the trick is if you see curly braces, even if it's on one line, you need return. If you don't see the curly braces, you don't need the return. It's sometimes useful just to create a quick lambda like this. Yeah? Would it be wrong if you put return in front of the n times 2 on the second? So the question was, if I put return here, what would is it wrong? I actually don't know if it would work. It would be an interesting experiment for you to try and let us know. My bet is, I don't know actually. I don't want to make a guess. Any other questions? So it's cool. It's like, this is just like saying const double equals 5, which is making a variable called double equal, which is a number, but we're creating a function. Yeah.
Is there any differences in how we call the function if we use this method?
Between these two here on the screen?
No, between method 3 and method 1.
So the question is, I'm repeating because of the stream, if we look at these three methods of creating functions, are there differences in how we call them? Actually, no. In all three of these cases, it's ADD brace or bracket, and then the two parameters. Yeah. There is a difference. Well, this is what I was saying before. This is a constant that you've declared called add, which stores a pointer to a function. This is doing something slightly different because this is not actually a variable, right? So JavaScript is probably internally creating a local variable, calling it add and blah, 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 but it's all sort of obfuscated from you. So there would actually be some slight differences, but not in how you use them. Yeah. Not in how you use them, and actually, because this is not a variable, you can't pass it around. You can't pass it as a parameter to other functions. That's the trick. These are variables, and whatever you can do with variables, you can do with these function variables. So you can pass them as callbacks, for example, which is what we do all the time, and we'll talk about soon. And these two are exactly the same. There's no difference here. So you call them in exactly the same way. They're doing the same thing. This is another example of just having an inline function declaration. Any questions on that so far? Do we want to run some of this code just to see it working? Yes?
You said you can't pass in method 1 into a function. Is that what you said?
Yeah.
Is that true?
Good question. I think it's true, but have you tested otherwise?
Like, for example, when you're using jest, if you want to compare the input to the output, you can do like test.
I need to look at the jest code, and I don't know what jest is doing, but you should verify that you can't use, we can do this now. We can verify that we can't treat that as a, let's just call it lec demo. This is TypeScript. So I should be able to do, well, okay, how about I do this actually? So I should be able to say, is it not shared? Oh, I see why. Oh, okay. How's that? You can't see this? Sorry, hold on. Why can't you see this? You could see the slide. This happened last time and it was a U fix, I want to say. Oops. Maybe it is a me thing. Why won't that even let me? Can you see that? What do you see? Okay. End the call. Or hold on, let me just stop screen sharing entirely. How's that? That's working? Okay, all good. And I'll just need to add this. All right, what did I want? I need to fix this up. So should be okay. Okay. This is all viewable? We're good? Well, I'm going to just keep talking. We're good, okay. So let's see what this does. So TSC, lec demo. That should work. Okay, that doesn't work. This should get called, which should call this, which passes in the add, which should call add with 2. So that doesn't work. No, because add, oh yeah. Yes. So let's just do, well, what I wanted, okay, let's just do this. Nothing there. Return 4. That should do something. Okay, yeah, so I was wrong. So this is what I meant. So maybe, so I guess in the JavaScript syntax or the JavaScript framework, it was populating the local scope with a variable called add anyway. And I suppose one of the benefits to the other approaches is that it's much more explicit that these are local variables. But I still think there are other nuanced differences. Like I don't know what properties there would be on add if it's an object or if, I mean, I know it's a function. So, okay. Also, by the way, does this code here make any sense? So we were just testing that we can pass add as a function parameter to some other function that accepts a function as a parameter. Just to test that this add could be passed around. Okay, and I want this here. All right, we've done that. So what this concept is called is this idea of first-class functions. There are many programming languages which have first-class functions, but it's this idea that we can treat the language itself treats functions as values. So like you have integers, dictionaries, objects. You can have functions. I mean, in JavaScript, literally everything is just an object. So functions are objects that are callable. But it means we can store them in variables like we've just seen. It means that we can pass them around as arguments. It means they can be returned as arguments. Anywhere you can use these types of variables or values, you can use functions. Not every language is like this, right? So C is not like this. C does not have first-class functions, even though we can do the same things in C. But what do we have to do in C in order to do some of this stuff? Yeah, we have to get the memory address of the function and pass the pointer around, which means we have to tell the parameters that the data type is a pointer to a function, where all of that just happens because it's a first-class feature of the language, first-class function. So in this code snippet, we are using that nice new modern function syntax. So we're creating a variable called greet. It is, what's the data type of greet? Which accepts a string parameter. Exactly right. So you're right, it's a function. And because this is TypeScript, we can be more descriptive and say, yep, so greet is a constant variable which is a function that accepts a string. Its return type is a what? Yeah, so the function's return type is a string. How do I know that? It's told here. And because there's no braces, in this case, the expression is a string literal, which gets returned. This is using, have you seen this syntax before? This is the templating string syntax. So that name parameter gets templated into the string. So this will say hello, and then whatever the value of the string that was passed in. So we can run this code. Do I have, I might not have that here, but let's just replace this here. How have you been, are you using TS Node or whatever to run, or are you doing what I'm doing, where you TypeScript it and then node it? How have you been running TypeScript code? TSX. Is that a package? Is that going to work? Hope so. Otherwise, I've probably just... No, that didn't work. I don't know what I just installed. That probably wasn't a good idea. No, it just doesn't... Yeah, that should be okay. I just want the... Okay, why is there no instructions for installing it?
It was on the start, so maybe like, I think 2 pages, and it was like TSX-I.
Where?
Just go back one.
Here?
One, go up.
Go to the tab.
Like just the one before this one.
Here?
Yeah, and it's
Oh, yeah, that is what I did though. So why doesn't this work? Oh, because this doesn't print it. That's all. Yeah, it did work. Okay. Okay, so if I go tsx like demo, yeah, cool. So greet is the function. It accepts a name string. When I call the function, I'm passing in 2 strings, one called Alice, one called Bob, which runs in the string template, hello Alice, hello Bob, and I'm just printing them both out here. Cool, any questions? Good? All right. So I rushed through this, but let's do it again more delicately, let's say. So instead of just passing in strings to these functions, when we do something with those strings, we can pass functions into functions, and it's a very common pattern in JavaScript. I will also explain after this demo why it's so useful and common, because there is a very good reason. It's not just to make our lives more annoying. There's a reason why we added this complexity. Maybe you can think about what the reason might be while we talk. So if we look at this code, there's 3 sort of components to it. So this is actually a very common pattern for formatting formatting functions. So we have this function called format name. It accepts a string called name. Yep, so we're looking here. We're all following so far? All right. Then it accepts something else. And this is where reading JavaScript syntax or TypeScript syntax is very important slash maybe difficult. So the key thing to here is that all of this is the second parameter to the function. If you can't in your mind see that, it means you haven't understood the JavaScript or TypeScript syntax. So even though it might go into separate lines, in fact, I can open it up here. Here. So what's the first parameter to format name? Name. What's the second parameter? Keep going. Good. Yeah. And? Returns a string. That's the second parameter of the function called what? Good. Format name. That's right. And format name returns itself a string, yep, which is the result of calling the formatter function, passing in the name that was passed to format name. Okay, put your hand up if you've got your head around this. What is this letting us do?
Change which function name is passed to, or like how we deal with name.
Change which function name is passed to and how we format name. That's correct. But why couldn't I, what's the benefit though of having this complexity? Because I could just write a bunch of functions which format the name the ways I want them, right? Do we see what I'm saying? And it would be much more simple. It's not about simplicity. So it's not about making the function smaller, because there's actually more complexity here, right? We have to acknowledge that. I mean, now our parameters are functions and they itself have functions, etc. There's sort of a reason why we want to do some of this. Part of it just comes back to everything being data, and data can be passed around. So what this means is potentially, right? So let's say I'm writing this big program and I need different ways to format strings, and you're importing my JavaScript library. It means that you would be able to define your own formatters, which are just functions, and you can pass the formatting function over to my say logger, right? Loggers are common places that we use formatters. So it just means that it's like a common language to describe these things. So I don't have to define all the formatters, for example. So other people that are writing code or using this library can just pass in, you know, a function that changes how the stuff works. Does that sort of make sense? I can think about a better way to describe it. So in this program, I'm creating two formatters, right? So two of those functions which just do some formatting. The shout function uppercases the whole thing. The whisper function just lowercases the string that's passed in. And so now my format name function, I have two possible formatters that I can pass out. One is called shout, one is called whisper. Will they both work? Now, why do they work? Why will it work? They match the type. Yeah, that's right. They match the type of the parameter. Do you see that? And so it can and it will run. But if this accepted something else, it won't work because there would be a type mismatch. So you can imagine why TypeScript saved us a lot of headaches, because we had to just assume everything would work in the past, which it might have actually worked, but we can't say that for sure. Anyway, then you can see over here, this is actually a really fun little demo, but I'm going to just comment all this out for now. So all in this file so far is just this formatter, two formatting functions, the actual thing itself, and then I'm actually calling it twice with the name Alice. And I'm just passing the response back to console log. So I'm calling format name, which is this function over here, passing in two strings, and then the shout and the whisper. Now, when I pass in shout and when I pass in whisper, what do you notice about those functions? They're not called, right? I'm not calling them there. So where do those functions get called? Can someone tell me what line number The function's actually, you're saying 10. Yeah, 10. 10. No, just 10. Don't hedge your bets. No, oh, sorry, thank you, I understand. Line 10. The trick is whenever you see the braces, that's the execution. So this is just a variable containing a piece of data, which is the function's location. Are we still following? Good. Okay, so if I call this TSX first class functions, I hit enter, look at that. We get line 16 is executing first. It's printing out Alice in all caps. Why? Because I used the shout formatter, which uppercases all the characters. On line 17, I'm using the whisper formatter, so I get all in lowercase, and we lowercase all the characters. It's pretty neat. And it means that, let's say I exposed this function publicly in this library, someone else could pass in a formatter that I haven't thought of.
Might be a dumb question. So when you're, I don't know what you call it, when you're doing like $sign, curly brackets, like variable, how come we don't do that in the format name with turning format on?
Say that again, and what line are we talking about?
So back in the previous script that you had,
Here?
yeah, so you had $sign.
Oh.
Yeah, and because that was
okay.
parameters. How come when we're calling formatter, which is a parameter, we're not doing that? Is that just because it's like one's a function
Okay.
and one's just a variable?
Don't get confused by this syntax. This is a string templating syntax of TypeScript. It's an optional piece of syntax, but it's kind of handy. So what this is saying is when you see backticks, which is what this is wrapped in, when you see backticks, what TypeScript or JavaScript is saying is this is creating a new string with the string literal, so this would be hello, comma, space. Then when you see this syntax $sign open brace, it unfurls the name variable into the string literal. So this is just returning the string literal. This doesn't apply here because we're not creating a string literal. We're calling a function on the string value itself. So we all know about, I hope we all know about object prototypes and things like that. Have we spoken about that this term?
Maybe not with our language.
So why is there a function called toUpperCase present on the S object? Because S is a string, but that doesn't answer, right? So string, if we go back to C, right, strings don't have functions on them. That doesn't make any sense. This doesn't work in C, right? So why is there that function there? Yeah, because everything in JavaScript is an object, and strings are objects, and on the object prototype, which is where these inherited from, there's useful helper functions for those specific data types. So string objects have available things like toUpperCase and toLowercase, and so we're just calling a function. My point is here is that what really matters is that we have an expression that returns, in this case, a string, and that's what this is. toLowercase is a function that returns a string, but that's the same here, except that this is a different way to create a string, but this is a way to join a string literal and a variable. What would be the other way of doing this? Yeah. So you guys are good. You guys are good. Sometimes. So you would do this. Now this syntax would no longer work, so you would have to do that. Well, you'd have to do comma, space, that, plus, and then you would do plus name. But just to save us this ugliness, it was a language feature. It's syntactical sugar. It doesn't really do anything.
On line 17, could you call format name again on top of that format name and put like a shell in there?
Like putting format name in wait,
So the question was on line 17, could we pass? The answer is absolutely yes. We can do anything we want. So we could do, so the trick is format name returns a string. So we could call format name, if I can type, with the result of format name, and then the thing would be shout. So what would the result be? Yeah, that's right. Yeah, you guys are good. Because why? Format name is a function that accepts a string. What's the result of format name? Okay, so we will get back a string here. Agreed? Which will pass into format name. And what format are we using? The shout format, so it'll be uppercased. All right. How are we going so far? Still good? Ready for more? Okay. All right. Let's see if there's a slide here before we keep going. Okay. So all those examples of functions are those which we defined, declared, and associated to a variable. But there are other ways to create functions, and there are cases in which sometimes we want to create functions that are ephemeral, they're one-offs. We don't need to store them, but we want to use them. So let's look. This is the exact same format name function. All right, nothing changed. Sorry, this is the slide I thought I was meant to be on. That format name is exactly the same, nothing changed. We can, of course, create shout using the one-line syntax. We can pass it in. Or let's say, in this example, I will never need to use shout again. All right? It's just, I need to call format name with a shout, but I never need to call shout again. Do I want to or really need to store it then in a variable? So I don't need to. Now I could, and probably you could argue that you should because it's more readable, but it's not necessary. And so we can create an anonymous function. In fact, we did this last week too. This is a callback. I mean, actually, this is still a callback, to be really clear. So let me, well, okay, that's not true actually. But there's a little caveat I'll explain in a second. But the point is, in this example, we're passing a function. We're doing the exact same thing here. We're just not assigning that function to a variable. So what are we doing? We're passing an anonymous function, anonymous in that it has no name. It's kind of a great name for this thing. But the anonymous function does exactly the same thing. And we're just passing it to format name in one line. I'm getting really annoyed by how these windows are laid out. Okay, so in this example, I'm console logging format name with the name Bob. So the string Bob. Now, what's the formatter? This is the formatter. Now, this is an anonymous function because I didn't assign or declare this function to a variable. So we pass this function to format name, and it will execute on line 10 exactly the same as it always did. And when this function executes, it will do this. Do we agree? Because that's what gets executed when this anonymous function gets called. And, well, how good is your JavaScript? So what will this do? Yeah, what you did. So it's going to reverse the orders of the letters, but Bob is a palindrome. So I think it'll still be Bob. Oh, but okay, capital B will be obvious. Okay, so there you go, that's nice. But okay. So these are.
Oh, is it like treating each character as an individual?
Yeah. But why is this working? Well, why do we have to split it? Yeah, exactly right. Yeah, so what we're doing is we're taking a string, we're actually splitting it by character so that each element is a character in an array, And then we're just doing array operations to it. So we're reversing it. That's the only array operation we're doing, actually. And then what are we doing? We're just joining it back to a string. Yep.
So the quotes are just like the delineator.
These are the split delineator and the joint delineator. By default, if it's an empty character, it's just character by character. But you could split like BO, and then you would get two elements in an array called BO and then B. So splitting is very, very useful. Cool. It is cool. I mean, like, what's cool about this is like, how many lines of C would it be? I want you to think about that. Maybe I need to think about that. Sorry? Right, but that's the point. Like, imagine if you had to do this in C. There is no reverse function in C, right? Yeah, you could find one, but okay, that's all work and time, right? And you've got to make money for your software company. Do you see what I'm saying? So they're very productive languages. But with the productivity, what do you get? You get less work, but what do you get? More complexity. I guess you could say slower too, actually. Yeah. But it's just much more complex. All right. Any questions? So we've got everything is data. Functions can be data. We can have function literals. If you think about it, that's what an anonymous function actually is. What do I mean by a literal? This goes back to the C days. Come on, don't let me down. Well, that's a bad idea. Right? What's a literal here in that line? I know you know what a literal is. Yeah, the literal integer 5. We use this term, I know we do. Yes, I get some nods. I've definitely used it in 151. So if in integers and strings and things we can treat them as literals, there's no difference to, this is why we can treat functions as literals. So an anonymous function, if you think about it, is just a literal value in that, you know, I could just console.log 5 here, right? In this case, I'm just using this literal value. It's not stored anywhere. It's not in memory, but I can still do stuff with it. And so it's the exact same reason I could, you know, is a function which, you know, returns n times 2. It's just a piece of value. Do you see what I mean? It's a literal function in this case. So what will that print? Yeah, it won't. Well, yeah, that's right. It won't print anything because n won't have anything to pass to it. But you know, maybe that was a better example. Sometimes we do actually. This actually looks really stupid, but sometimes we have to do this because the data type was a function. Do you see what I mean? But that's probably a poor. Anyway, okay, I'm getting. All right. So we're really going well on time. So first class functions, we can treat them as variables. We can pass them as arguments. They can get returned and they can get stored. Why is it important? It does enable conciseness. So we had a one-liner that would take 5 or 6 lines of JavaScript without it. And if it was C, it would take many, many more lines. It can be more readable, especially if you're familiar with JavaScript and TypeScript. I think at the beginning it's less readable. We can have anonymous one-off functions, which really does, you know, support smaller, more readable code. There's a great software engineering saying, the only code without bugs is no code, right? So the less code you write, the smaller a code base, the less surface area there are for bugs. So there is actually a possible benefit for writing, we always want to write less code, to be really clear. But I think more importantly, it's the foundation for callbacks, higher order functions, and functional programming, which we're going to talk about in the second half of this lecture. But really importantly is this one, is this idea about callbacks, which actually right now you have all the building blocks for callbacks. In fact, like we are using callbacks here, but we've not really motivated it sufficiently, and we will do that. But first, we will do a Kahoot, then we'll do a quick break, and then we will get onto it. Does that sound good? And I fixed the Kahoot this week so that you should have a fighting chance. So there's 40 of you here. That means 10 haven't joined. That's so sad for me. Okay. We ready to start? People are joining. Let's go now. Okay. Which property is shared by both URL query strings and post bodies? Okay, most of you got it. That's still good. All HTTPS traffic is encrypted. So that would kind of tell you that the query strings and the post bodies are encrypted. It would be a real disaster if we cached post bodies. Why? They might contain things we don't want to cache. Also, they might just be very large over and over and over. It doesn't make sense to cache it all. We cache query strings. How do we know that those are cached? Yeah, your browser history is just a cache of your query strings. That's exactly right. So we know that that's true. And again, I said this last week, but it would be very, very bad if all the post bodies that were passed around were stored in your server logs. They would get very large. Right? Imagine 1 million people. Think about it. The post body is every data associated with a request. So if you're Facebook and you have a button that's like or Instagram, you've got an upload image button, the data for that image will be in the post body. So that means you would cache that's not a cache. I mean, if that was in your logs, that's a disaster. It's insecure and it's too big. Make sense? Okay, a client sends a delete request to the following API. Which CRUD operation would it map to? I think this one's easy. Does it not skip it if everyone answers? Oh, there's just more of you. Yeah, okay, cool. Sometimes it is just what it looks like. Who did update? Was it just a guess? Yeah, fair enough. Create is post. Update is patch. What's the other one? Get is read, but delete is delete. Oh, fair. That's bad. Okay. Question 3. Your server returns the status code 403 to a logged in user. This one is a bit mean. What does this mean? Okay, very good. I think it's also inferable from the question itself, because if the user is logged in, then they're clearly an authenticated resource. So if they're getting a 400 level error, which is an access type error, it might tell you that 403 is that you're not authorized. Do we know the difference between authentication and authorization? Is that obvious? It's very distinct. So authentication is, do I have credentials to log into, say, this website? So do you have a ZID is authentication. Authorization, which is, can you act as like a lecturer? So my ZID allows me to act as a lecturer because I'm authorized to do that. But we're both authenticated, right? You're just lowly mere students and you can't, edit grades, I hope. I can't edit grades, right? Well, I guess I could. So it's not super great, but there we go. A lot of you did yellow, result.json. So the result object does not have a JSON field that is callable like that. So honestly, this one's just a bit of a memorization question. But also, I guess it's an exposure question. You'll just see JSON.parse all the time. So you turn result.body into a string, but it's the JSON representation in a string. And then JSON.parse takes a string, turns it into an actual JavaScript object. All right, last question. Oh no, second last. So what's Swagger used for essentially? Or open, what's it called now? Open API. Okay, very good. Very good. So those YAML files that contain all the descriptions of the endpoints are machine readable. YAML and JSON, these are machine readable formats. So one of the things we can do with those machine readable formats is, say, spin up a little Swagger website so that a human can read all the descriptions too. But that's what Swagger is designed for, or Open API. I guess they changed the name. All right, last question. In a jest test, you pass it, this will be a tricky question, I think. You pass a JSON response body and compare it to some object that you want to test with. What matcher should you use? Yeah, very good. Why a strict equivalence check?
I've never used the other three.
You just guessed. Oh, you just haven't used the other three. Okay. So some of them may exist. Well, what is the, yeah?
I searched this up like the other day, so I hope I'm correct.
Okay.
It checks the type as well.
Yes. Okay, that's all. Okay. So the thing with JavaScript is everything is a what? Object. So different things could look the same. Strict checking, it's actually used in a few places. You might see it in TypeScript definition files where use strict can be true or false. What it does is more strictly validates two objects in any circumstance, not just in jest, for example, but jest is a good example. So, okay, let me be really, really clear. You got two objects. One contains the key name, the value COMP1531. Let's say one contains the key name, the value COMP1531, and the key age value 40. They are equivalent because they both have the same key and the same name. So depending how you do the test, they might return different values. So if you've got, say, object, the smaller object on the left, which is name 1531, and the large one, which has the age, and you say, okay, for each of the keys in the left object, check if the key and the value is present on the right object. Will that return true?
No.
I need a whiteboard marker. Do you have one? Oh, that was ambitious. Okay. So object over here, name. I don't know if you can all read this. And then over here we have name, comma, age 50. Can you see that? So if let's say I wrote some naive checker that said for each key in this object, so what's the first key? Does the key exist on the other object? And then I said for each value matching to that key, does it match? So then I say, okay, so are the objects equivalent then?
No.
But look at how I implemented the check. So I took the object on the left and I said, go through all the keys and all the values. Are they present? Yeah. Yes, they're present, right? But are they present? But you don't.
Like, if you're just checking for that specific one, then yeah, that is equal.
That's right. The strictness basically means not only do all the values have to be present on both objects, there can't be any other differences. You've got to understand in JavaScript, objects are often huge with many. Look at the string object, it's got many functions on it. Yeah? So, and in different versions of JavaScript, potentially those change. Sometimes what it means for two objects to be equivalent, all you really care about, often all you really care about in JavaScript is that the data that I want is there. Because there will be many other objects on these values and keys on these objects. But if I want not only the data to be there, but I really want to know every single property about the object, we can have strictness. I mean, maybe there's a better description online of, I already am in the browser. So let's see how they describe it. So to equal ignores object keys, and what it means by ignore is that it won't cause the test to fail. So it ignores certain things. So for example, if there are keys with undefined properties, undefined array items, array sparseness, or object type mismatches, to take these into account, use toStrictEqual. ToEqual won't perform a deep equality check. Only the message property of an array is considered for equality. 2 equal won't perform a deep equality check for 2 errors. This part is throwing me. I thought I knew what this first part meant. But it is a deep check, yeah, so then I don't understand that. But, okay, anyway, just that component. Okay, number 3, terrific sugar glider. Who is that? Very good. Number 2, stellar firefly. Very good. An athletic ferret. Okay, so you need to take screenshots of your podium, and I owe you all Pokemon cards because I haven't bought them yet, but I owe the last week people. I don't know where I have a whole deck of cards, by the way. They're completely missing from my office, so clearly I've had like a break-in or something. Okay, good job. Shall we have a 3 to 5 minute break? Come back and keep going? If you've got any questions as well, please feel free to come up. I will just talk about, so I don't have any extra slides on the whole callback thing I've been going on, so I'm just going to explain it now. Why is it more important in JavaScript? Well, it's not even a JavaScript thing. Why in the type of code that we're writing in this course is something like a callback very powerful? So if you think about the types of programs we ran in C, right? It was a series of instructions. They ran top to bottom, or from main or down. And they run as fast as we can make them possibly run. They execute in order. Something's achieved and the program ends. That's not the case in say, server code, where we're reacting to things happening. It's reactive programming. There's actually a really fantastic JavaScript library called RxJS, which is a whole ecosystem of reactive programming that's even more complicated than this, but put that aside. Why is it reactive programming? Well, we're often reacting to something happening like a server request. So when do I want my GET request code to run? I don't know. And I don't know in the sense that I'm waiting for some user to hit an input. I literally have no idea because it's whenever the incoming request occurs. So often what we do is we say, well, when an incoming GET request to an endpoint is executed, just call the callback function. And so whatever callback function we pass into that HTTP request file, it'll just call the function that's passed in. And that's more typically what I think of, at least when I think of a callback. It's like a function that gets passed in, but it will be called back at the appropriate time, right? Yeah, I think that's a good way of talking about it. All right, so when we have first class functions, we actually have some language tools to do things with them. These are functional programming ideas. They may not be purely functional programming. The functional programming purists will, whatever. I think they're pretty good, actually. These are three incredibly common functional programming paradigms in JavaScript: the map, the filter, the reduce. In fact, have you seen these keywords anywhere? I'm sure if you've been looking online for some JavaScript code, you've seen it. Who's seen them before? A little bit. Who's like, I don't know how this works, but I pasted it in and it worked? Who's like that? But yeah, sure. So we'll actually understand what these are doing. Cool. Essentially working with arrays without writing loops, but they are all, I think so, they are all callback-based models or functional models. All right, let's have a look. So far, if I've got an array of values and I want to do things to each value in the array, what do I typically do? If we're C-style programmers, we set up a for loop or a while loop. We iterate over each element using an index or just using the value lookup. And we do something in the body to each element, right? We've seen that thousands of times. Map, filter, and reduce let us express the same ideas more declaratively. They describe what we want, not how to loop. So if you think about it, C, you're telling the program, loop over these values and do something to each element, and I'll tell you exactly what to do. Why is this important / relevant? There's, I think, two reasons that come to my mind. There may be more. Number one is kind of obvious, but you could write a for loop improperly. So what do I mean by that? You could, 90% of the time when we write a for loop over an array, we look up the index and we're doing something with the value. Agreed? You could use the index incorrectly, right? Or you could do it correctly. You could do something like use the index and use index +1 to get the next value. But all these little tricks that we do require more thinking and cognitive load because, okay, now I need to make sure that if I'm the last element, I don't do I +1 because then that'll be an index array, right? Okay, so let's not do that, blah, 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 blah. What these ideas are more functional expressions of the common things we do in, say, a for loop. And honestly, if you're a proficient TypeScript or JavaScript writer, or even Python has these ideas, you actually fairly commonly don't ever need to write a for loop. just with these three ideas, map, filter, and reduce. It's quite kind of interesting. And if you use them correctly, they're very, very safe. That's the key difference. How many times did we write a for loop in 1511? I know I did it in the lectures even, and we get an off by one error. Yeah, or we use the wrong value because I positive or negative, we're in the wrong direction, right? Like things like this. This happens all the time. These ideas save us. All right, so we start with map. It's probably the most useful. There's other benefits to them too. We can see they use much fewer lines of code. But the definitions of these functions is very, very, very important. So let's look at map. It takes an array of n size. Now this is just a given with all of these functions. They all take an array, and they all take an array of n size. We don't care how big the array is. That's kind of like a for loop. And it produces a new array of the same size. Now, why is it called a map? It's in here. We're mapping each value to a transformed value, but it's a one-to-one mapping, if you've heard this term. So that's the way to think of it in your mind. So you've got a bunch of values in an array, and I want to apply a transformation to each value of the array. So let's say really simply I've got an array of strings. I want to lowercase all of them. That would be a map. Does that make sense? For each value in the array, you want to go through it, apply the transformation, which would be to lowercase, return it, and store it in a new array. Make sense? So mappings are one-to-one transformations.
On new arrays, it's a shallow copy, isn't it, where it's actually pointers to the element?
You've kind of overcomplicated it, but let me repeat the question for everyone's sake. So you said by new array, what did you say? It's a shallow copy and they're pointers to the previous values. I think what you're trying to get to is, does it transform the array or does it return a new array? And that's a very good question. And the term is, I think, destructive. So is the function destructive? Now, what I mean by that is, if I call map on an array of names and I'm lowercasing them all, do the pieces of memory, do the values in memory change, or do I get a new array? But that's why we have the keyword here, new. Now, there is no shallowness or depth, deepness here because it's a transformation. So what that means is to answer, do we know what shallowness and deepness means in terms of objects?
No.
Who does? Do you want to explain it?
Like the object itself would be the variable you use in your code, and if you change the variables inside the object, they are constant between all of the different times you've defined the object and these other functions.
To me, all it means is, so if this is an object, and the second key on the object is itself an object, a shallow copy won't copy those inner keys, whereas a deep copy goes deep into the object and copies the whole thing. So in a map, in a transformation, that doesn't make any sense. What makes sense is it totally depends on what the transformation does. Okay? It'll make more sense when we have some code. So let's look at this program. We have an array of numbers. Yep. Agreed? We're on the same page? Here's how I would do a transformation in a loop. Now, this transformation is just to map all the values from their current value to their value doubled. That's the mapping that we're doing here. Now, how do I do this if I'm a C programmer? We start a loop, a for loop. We get an index. We use the index to look up the value. We take that value, we multiply it by 2, and we put it somewhere. Where am I putting it? In this example, where do the mapped values go? Into a new array called doubled. Yeah. So is that a map? Yeah, I agree. It was 4 lines of code. It's straightforward still, but yeah, that makes sense. Okay, let's look at it with the map function. It's really cool because it uses these anonymous functions that we've been talking about. So let's break it down. The first thing I'm doing is creating a variable that I will store the new array in. So that's what this is. Why? Okay, here's a question that if you get this correct, you're in a pretty good spot. Why does TypeScript here know the type of doubled? Because it's not part of the type definition. Do we agree it's not here? So if you were just if you were a UCID student that didn't know what you were doing and you read this line of code, would you obviously know the type of doubled?
No, you wouldn't.
You wouldn't. It's not here. It doesn't say it. There's no colon type of the result. Do we agree? So how does TypeScript know the type? Who said that? Sorry, what did you say? Yeah, it's the return type of the function. But how does it, what's the type? Well, can I ask you what the type is? Not a number. A number array, an array of numbers. But why is it obviously an array of numbers?
Because the map only works on arrays.
Yeah, but why is it an array of numbers? Why isn't it just an array? What did you say? Actually, I was wrong. You were right. It is just an array. I was wrong. Yeah. Because map always returns an array. Because map does something very specific. It transforms an array into a one-to-one mapping, which means you always will end up with an array. Do you see what I'm saying? So it knows that the result of calling map will always be an array. So in those cases, it infers the type. So this doubled will be an array. Now, what type of array?
A number array.
Who thinks a number array? Put your hand straight up. Who thinks something else? No one? So you're all wrong. Why? Well, okay, hold on. Maybe not in this example. In this example, it will be an array of numbers. Sorry. But will map always return the same type of the array passed in? Well, it depends on what the mapping transformation does. What if my transformation was toString? Okay, then the type will be a string array. So we don't really know. Okay, so all of that to say is we create a variable called doubled. Its type will be an array because it's the result of calling map. Map returns array. Map is being called on the numbers array. So the way we actually call these functions is that they exist as, what was the word I used before? Where did the function come from? So I didn't import a library called map, did I? No. Where did it come from? I used a specific word? No, you're... Yeah, who said that? Yeah. So the array object prototype has relevant array functions. Do we know what a prototype is? An object prototype? In TypeScript, I mean. Well, you said maybe. Do you want to? You're real. Do you want to try? Hold on. Do you want to try?
Like the default list of settings for each object, I guess.
The default list.
Like generally, it's like when we define a struct and like all the things.
No, sort of.
Properties that every object of that type has.
Yeah, but literally, an object prototype, this exists in C# and other languages, which is where I probably learned it more. So there is an object in the JavaScript runtime. There is the array object prototype. And it is a literal object with curly braces, a dictionary, with these arrays and their definition. And when you create an array in JavaScript via any mechanism, it literally copies that object and then adds the new stuff. So that's why it's called the prototype. It's like all of them, it's like in science fiction or whatever. It's like isn't it like Adam was a prototype of man? Let's not get biblical. So it's like all features of an object have that subset, and then we can add stuff to them. But in reality, I'm being quite mean, and you were all right when I was saying, yeah, they're just the things that we know should be on those types of objects. So map comes from the array object prototype, and what are we passing to map? Well, how many parameters does it accept? One, that's very good. What's its type? No, don't say number. You were doing so good. No. What's the type of the parameter for map? Yeah, you guys are saying it. It's a function. It's a function. We can see that, can't we? That's a function, isn't it? What type of function is it? An anonymous function. So map takes a function. It kind of makes sense because how do we transform things in mathematics or in functional programming? With functions. It's all functions. That's function. That's why it's called functional programming. Who would have thought? It's functions all the way down. All right. It's kind of interesting. So the map logic, the way I think about it, whether or not it's true, is that the map logic inside it is something like the for loop logic, where it calls map and passes in each element. So therefore, the parameter type to the function has to be the type of the value in the original array. Does it make sense? So if I've got an array of numbers, which I do here, what parameter does the anonymous function need to accept? What type? A number, yeah. Right? Make sense? It's like if I've got an array of numbers, 1, 2, 3, and I say dot map, which I can do this, by the way. I can call map on an array literal. It's very useful sometimes. Do you see what I mean? And I call map. N is a number, and you need to map that as, again, that mapping to each element in the array. So these are numbers. So this needs to be a number. Right? And then we go off and we do something in that transformation. So what's this transformation doing? Sorry? Yeah, it doubles it.
Does the map function prototype in the array object specifically define it to take in one parameter?
That's a good question. So does it specifically so is this array, what you're asking is, the array parameter, is it typed to only accept a single element? Is that right? So I think the answer is yes, but you can just hover over it and check. There could be overloads, but not for map. I'm pretty sure for map there's only one. There's a really cool question here that no one's asked yet. That'll be a type error, but there's a better question, sort of. How does it need
to take in a function?
That's not where I thought it was going to go. Let me answer the question. Well, who's done object-oriented programming? Or who's in it now? Or you've done it? Or we can ask it. We can ask Liam. Okay, we're cheating. But so, how does the map function, which is a prototype on all array objects, know the type of the element to be passed in? Why is it number? Yeah, so what's it called again? It's called type templates, right? Templates. So what did you do in OOP? Anyway, we see the capital T, right? Or is it not templates? Yeah, generics, that's what I meant to say. Yeah, sorry. Anyway, okay, I'm getting off topic. What did you really ask?
Oh, sorry. I was just wondering, how does it know that it needs to pass in a function?
Because that's the type of the parameter in map. We can put the, okay, let's go to VS Code. So map filter reduce. This is the same lecture demo. I can hover over map, and we can see that map is a function on the array prototype, and it accepts, it only accepts one value, and that is the callback function. So this is, we're coming back to callbacks. The callback, it can actually, looks like it can accept multiple things. So no, that's not true. It probably does that itself. All you pass it is yes, you can get the value and the index and the array itself out of map, but you probably shouldn't be doing that. What you really care about is callback function that gets passed in. These things let you see things like the current value, the index in the array, but for proper functional code, you shouldn't really need to use them. But there are some cases where you do. Can anyone, okay, I'll explain this first and then I'll explain why that's there. Okay, so doubled equals numbers.map. It takes in each number, and for each number it applies the transformation n.2 and populates that in the new array called doubled. TSX, map, filter, reduce, we get out 2, 4, 6, 8, 10. It's doubling each value. Is that pretty cool? This would have been 5 lines in C or even in JavaScript. Do we have any questions on map?
You map every second number.
Okay, can you map every second number? So there's 2 answers to that. First, you can do it with those optional parameters that we spoke about. So you would need to look at the current index of the operation that's happening in the map, and if it's even, you do something. If it's odd, you don't do it. But then it's not really functional because you're using state. The whole idea of functional programming is that there is no state. And what state means is no local variables in a way. So we don't care about I. If we care about I, that's procedural programming, and that's not functional. Functional programming is very elegant because you don't do silly things. Because you just assume I have to apply every transformation on every element. Does that make sense?
Yeah.
Was there a hand there?
No. Well, there was, but then
Yeah, I was going to say, don't gaslight me. Where's the other hand? Yeah.
what would happen if you passed it like an array of objects? Would that just not do it?
Oh, that's a good question. So what if this is an array of numbers, but a number is an object, don't forget. But what if I had like a custom object sort of definition? So absolutely that would work. Look, we could just do this, you know. This is super, super, super common. We could just say it's an object, or we could say it's an object with the key name. And the transformation will be to say n.name is equal to, or we could do n.name.to upper. Do you see what I'm doing here? So for each object in the original array, access its name and uppercase it. So it's very common to do map transformations on objects. This is not destructive. Why did you think it's... Oh, yes, that's a mistake. The call. That's annoying. We're back? Yeah, so you're right, whoever I was talking to. Yes, we just want to return that. In fact, yeah, this is right. Yeah, this is right.
Difference between like curly brackets and like normal brackets in your...
Here,
Yeah.
what I'm saying here is that the return type of the function is an object, but I'm not typing the object because I was lazy. So if you see empty curly braces as a type, it's saying that it is an object with any property. This really should be name is string. Good catch. What do you really do if you're a better TypeScript programmer? You might define the type and use the type via name. Because we need to use it here and we need to use it here. And now it's getting complicated. Yeah. Any other questions?
Why the error?
Good question. Oh, that's not too uppercase. But that's still got an error. Yeah, that's okay. Yeah, yes, that's right. I didn't put it on an object with a key name. It should be an object. Oh no, no, this should return an array, right? No, that's not right. That should be right. And the value will be an object with name, and name is the name to uppercase. I have a feeling that this is something to do with the potential for there not to be a value returned. Oh, no, I might have just had a brace order issue there. Yeah, that each element that gets returned should be an object because we have an array of objects. Okay, let's comment this one out for now. We have the two. Okay, that's basically map. I think it's the simplest of the three. Is this being shared? Nope. How's that, Liam? I think it's the simplest of the three. It's a one-to-one mapping. The function gets applied to each element. Don't forget, this is really common. If I don't have this, it doesn't change numbers. Yeah? So this is called in place or not in place. This is not in place. So you have to assign it back to a result. Okay, filter. Filters, if you understand conceptually what map is doing, filters are only a little bit more confusing. We take an array of any size, and we produce a new array of size 0 to n, keeping only elements that pass a test. So what this is saying is, filter returns an array of the same size or smaller. So it can never be larger. Elements are unchanged. Again, so it's not in place, so we have to return it and store it in an object. But conceptually, what is the filter function trying to do? It's in the name. They're all in the name. You apply a binary filter to each element to determine whether or not you should include it in the resulting array. Okay, what does that mean? If my filter is so everyone put your hand up, every single one of you. Now in your mind, keep track of, so who doesn't have their hand up? Liam's excused. Okay, I won't be mean. If in your mind, if your first name starts with the letter A, that's my filter condition. So now I run the filter, put your hand down if your name doesn't start with the letter A. Okay, we just applied a filter. All right, it's that simple. There's a reduced set of you now who have your hand remaining because your names all start with the letter A. So what if I want to do something on a set? Right? Remember, these are all operations on sets. Filter, map, and reduce. Here's an even simpler example on the screen. If is even is a really simple one. Again, you start to get an idea here, right? Like, it's another 4 lines of code if I'm using a for loop, or I can apply a filter. The trick with the filter, this is the kind of like, maybe it's a bit confusing to get your head around. Maybe I'm such a great lecturer, you're not going to have this problem. The function, the anonymous function or the function that gets passed in, right? So with map, it was the transformation that applied to every element. With filter, what's the function doing? You can tell by looking at the code and then yell it out. Get more generic than that. Get more generic than this. So don't talk in language of this application.
Filter even numbers.
That's still, if I hear the word even, you've got it wrong.
What's the question?
What's the function callback in the filter function's job.
It's choosing what objects to include.
That's closer. It's choosing what objects to include, but let's talk really specifically. So what does it return? Okay, so basically, it's a function called on each element, and if it returns true, we keep the value. That's it. It does not have any intelligence, awareness. I used to get confused by the filter function. So let's look at the example down here, but we'll look at it over in VS Code. What time is it? Okay, bro. So this is the same, right? Do you see how it's the same as map? So we pass in a function of each element. It returns a Boolean, and the Boolean is just a check on if that element should stay in the resulting array. Now in this case, what I'm doing is I'm doing a modulo by 2, which is, we've seen this before, right? So this is how we check for evenness in a value. If there's no remainder, that means the value returns true. The value is even. And that means that it will evaluate to true. And if the value is true, the value, the associated value is kept in the resulting array. Does that make sense? Does it really make sense? So if we can run this, and we get 2 and 4 because 2 and 4 are even. But my point I really want to make is, what would this do? Yeah, all right. Does that make sense? So it's all we care about is something that can get applied to each value and return a Boolean value. And that's filter. It's so useful. Happy? Are we ready for the hardest of all? It's scary. It's not too bad. Reduce. It's just like the least intuitive, I think. So you have an array of values. And you always return back from reduce. You actually don't return an array. So what reduce is a reduction, which is where the name reduce is. Like, who cooks a lot? Are you good at it?
Of course.
What's a reduction?
You burn off the water.
Okay, yeah, good. Is that what you're going to say? So it's when, making like a sauce and you burn off all the water and you're reducing it to something smaller. In functional programming, we're reducing a set of elements to an atomic sort of, what's the word? Most atomic reduction that we can possibly do. Okay. A very common reduction is something like an aggregate, which is what we're doing here. So if I'm summing a bunch of numbers, and we so far we think like C programmers, what do? I create a for loop, I create a sum value, and I assign sum, the value of sum plus the value of each index element in the array. Happy? All agree? Okay. Another way to think of addition is via a reduction. So we pass to the reduce function we pass it the accumulation. So we always pass it a function. The function takes 2 parameters. The first thing it takes is the number. Now I'm getting lost. The accumulator there is the sum. So it's keeping track of the running tally, because internally it needs this sort of idea of state. This is much more like recursion if we did that in 15112. And then it also passes n.
Is the accumulation like the starting sum? Like, you start a sum at 0 and then you start adding and that's sort of thing?
No, the accumulation is, let's have a look.
It's like the accumulation sum.
It's the starting value. That was really, well, no, that's not true because we need an array, don't we? This is using numbers, so 1, 2, 3, 4, 5. No, that's not true. So So if we call reduce, where are we calling it? Here. Oh, yeah, numbers.reduce. So we're calling reduce on the numbers array.
Is the issue what accumulation?
Accumulation is the callback, which is yeah. So yes, do you see it's happening here? I told you it's confusing. So sum's the result, which we're also passing in as the value that's storing the sum. So it is a recursive operation. And then n is the number, and I think this is just used internally to keep track of how many times it's been applied. N is the current value being reduced. That's what it is. So, yeah, which is just each element in the array. That's right, yeah. Did I save this?
For accumulation.
Or is it like where it starts to accumulate from?
Well, like you know when you make like a sum loop.
Well, we can,
Make a variable called sum. You usually start at 0 and then add the first.
yeah, if this is 16, then it's just the starting value. That's right, yeah. Yeah. But I guess the problem here, well, it's not a problem, but the reason why it's so explicit is because reduce is not just a sum used for sums, it's used for any operation which can continually be applied on itself to reduce to a single value. We should find some good, simple examples of functional reduce operations. Concatenate, maybe actually is probably using something like a reduce under the hood, but I can probably be using something more efficient too. Let's see what this guy's got to say. Oh, this isn't shared? Yeah, okay, so that is the initial value. Okay, the reducer function gets stored in the accumulator. We spoke about that. I just wanted an example. This doesn't look like an example. This is just doing sum as well, so that's not super useful. A quick practical example of JavaScript's reduce function. And it's just sum. Okay, really cool. Okay, again, this is why I'm the least confident with it. To be super honest, I use it. I would never write it, to be honest. It's like complicated. I never get my head around it.
We like also use it for like stuff like multiplying, dividing.
Yeah, of course. You could do, well, yeah, but it wouldn't just be multiplying each element. It's multiplying each element by the next element.
Yeah.
So it's, yeah, it's not factorial, but it's like, this would be 1 times 2 times 3 times 4 times 5. Yep. I have seen, I'm just trying to think, I've seen other interesting examples of them before, but anyway. Okay, and the other, this is really cool. So chaining is where things get very, very interesting. So let's just look at this example. So who was asking about objects? Can we do this to objects? I think it was someone over here who's no longer paying attention, but we can do this. So this is like a nicer, larger example. So here we have an interface, which is just like a type for an object, called a cart item. So it's got a name, a price, and whether or not that item is in stock. So we have an array of these objects, yep. So we have a laptop, a mouse, a keyboard, and a monitor. They've all got a price, which is a number. They've all got this in-stock Boolean. That's really cool. What if I need to do some series or some sequence of activities onto this array? So we can chain these functional calls. This is the other benefit of functional programming. It's because everything is an array and everything is a function, they can be chained. So what we're doing here is getting the total. I imagine what we're going to do here is getting the total of the items that are in stock. So think about what we would have to do in a for loop. We'd have to loop over each element, have an if statement for the in stock. If it's in stock, get a running total sum, add to it. Agreed? So this puts everything together. It'll use a reducer with a filter, so it'll only occur on items that that Boolean condition passes, and that Boolean condition is very likely to be in stock. This is such a nice way of using filter, because there's a computed property on the object that is our filter condition. We're not actually running an expression. So the first thing we typically do is filter. This is always the case. Why? Because it's should I do things to this object in the array. So we filter first. The order matters here because they're chained. So it's the result of calling this filter gets passed to the map. And what does the map do? It exfiltrates, I should get some points for using that word, the number from the object. Yeah? So the item had a price. Mapping is taking an object with a key called item and a value called, which is the value, and just returning just the value. It's not doing anything crazy. It's not doing anything to the number, but it's so what will the return type be of map? Very good. And what was the input array type? Very, very good. Did we all hear that? So we started off with an object array and we mapped it over to a number array, exfiltrating the value. And then we reduced that value to a sum using reduce. So we started off at 0 and we ran the function sum is equal to sum plus price over and over. But in 3 or 4 lines, we get this chained out to a single total. Nice? Good little summary with how it all works. There was a couple more slides, but we're out of time. And I can do them on Thursday. That's just the chaining. Yeah, this one I always get tripped up on. This is even worse. Let's leave it for Thursday. I remember, yeah. So it is very useful, but so we'll talk about higher order functions on Thursday. We've got 2 minutes, I guess. Higher order functions are functions which themselves return functions. Commonly used in languages like Python as, has anyone ever used or heard of a decorator? Anyone? That's a higher order function. So this is how you would implement something like decorator logic. But we don't have time or mental clarity for this now. But they're function factories. Cool, I'll let you sit with that. We'll talk about them on Thursday. All right, thanks everyone today. That was really fun. You'll see this code anytime you do JavaScript and TypeScript, and my hope is that now you'll have a slightly deeper understanding of what's going on.